Welcome back. This is the third lesson recording for IM2, December 7th, 2020. So now we're going to talk about greatest common factor in polynomials. To do that, let's think about what we actually have done. Multiplying using distribution. So if you have 3x squared multiplied by x squared plus 2x plus 4, 3x squared was multiplied to x squared and then 2x, and then to that you added multiplied it to 4 to get 3x squared multiplied by x squared plus 3x squared multiplied by 2x and then 3x squared multiplied by 4. And the final answer will be 3x to the power of 4 plus 6x to the power of 3 plus 12x squared. Now, what if we were to look at 3x to the power of 4 plus 3x cubed plus 12x squared? That's the answer that we got. What are each of these terms? They are 3x to the power of 4 is really 3 multiplied by x multiplied to itself 4 times. X times x times x times x. Whereas 6x cubed is 2 times 3 because 6 can factor as 2 multiplied by 3. Those are the prime factors. And then x to the power of 3 is x times x times x, whereas 12x squared is 2 times 2 times 3 because we said that 12 can be represented as prime factors of 2 times 2 times 3, and the x squared is x times x. So that means looking at all the factors between the three terms, what are the factors that are common to all three of the terms? We have 3, 3, 3 being common, and there are two x's here, there are two x's here, and there are two x's here. We can't say any more than two x's because we don't have any more x's here. Although we have one more x here and two more x here, there are no more x's here. So the greatest common factor is 3x squared. Okay? So we can say that the first term really is 3x squared multiplied by x squared. And the second term, 6x to the power of 3, is really 3x squared multiplied by what's left is 2x, right? 2x. And then 12x squared is really 3x squared multiplied 2 times 2, which is 4. So we can rewrite this as we can take out the 3x squared that is common to all three of them and take that out outside the parenthesis and write the remaining x squared plus 2x plus 4 here. And you know that this is actually what we started off here. Okay, so basically looking for the greatest common factor is doing the multiplication using distribution backwards. Okay, so instead of multiplying, we're looking at this and looking at what are the expression that we can take out as being commonly multiply to all the other terms. All right, so let's try this. Okay, so factor out the greatest common factor, 9x squared minus 12x plus 6. So to do that, you need to look for the greatest common factor in numbers first, okay? In the coefficient, number factor in the coefficient. So looking at the coefficient, we have 9, 12, and 6. So we can say that 9x squared is really 9 times x squared minus 12x plus 6. And 9 is really same as 9 times 9. That's prime factor here. Okay, and then 12, we're just going to say 3 times negative 4 because we're looking for a number that is common to all three. What is common factor to all 9 and 12 and 6? Okay, so we can see that 3 and 3 and 3. 3 is common to all three terms, right? The blue term, pink term, and the orange term. 3 is common to all. So we can take that out outside the parenthesis and write down what is remaining. That's 3x squared here, and then negative 4x here, and then 2 is going to be here. And if I was to go backwards and multiply this out using the distributive method, you would get back to exactly what you started off with. Okay, so that's a quick way to check, am I doing this correctly? is by multiplying 3 to each of the term and see if I'm getting the original expression. 3 times 3x squared is 9x squared. 3 times negative 4x is negative 12x. And 3 times 2 is 6. So it comes out to be correct. All right, so at this point, I would like you to pause the video and see if you can factor out the greatest common factor for these two polynomials. Okay, let's go through the answers. Okay, so we're just dealing with the numbers for now. Okay, 6. What are the common factors to prime factors of 6? That's 2 and 3. What about 27? That's 3 times 9, so that means it's 3 times 9. So the common factor is 3 times 3, and 3, the only factor is 3. Okay, so then looking at this, what is common to all three of them? Okay, so only thing that is common is there's 3 here, and then 3 here. So 3 is the only number that I can take out. So that means it's going to be 3, take out 3, then you are left with 2 and x squared. So it's going to be 2x squared. And then take out 3, you still have the 2 here, 3 here, and a 3. 3 times 3 is 9. So we still have 9, but we still haven't dealt with the x here, so the x stays. And then we took out 3. 3 times what is negative 3? This is actually 3 times negative 1. I do need to write that there. Okay, so that means it's negative 1. And again, to check if I am doing it correctly, I can just quickly multiply this to make sure that I did not make any mistake. 3 times 2x squared is 6x squared. 3 times 9x is 27x. 3 times negative 1 is negative 3. Okay, and that's what we started off with. Okay, all right, so let's try the next problem. All right, so 4x, 16x, and 8. 4, 16, 8. Before I just go into prime factors, I can think about this. 4, 16, and 8. I can see that 4 is going to be a factor to both because I can see that 4 times 4, and this is 4 times 2. Yes, I can go to prime factor and say that this is 2 times 2. And so I can go further and say that this is 2 times 2, and this is 2, 2 here, and 2, 2 here, and then 2, 2 here. Okay, then from here I can say, okay, well, common to all of them, I see there are at least 2 of the 2s. So 2, 2, 2, 2. And for the third term, I can circle the 2, 2. Okay, because I know that 2 times 2 is common to all. All right, so then I know that 2 times 2. What is 2 times 2? That's 4. So I can take out 4. And what am I left with? I still am left with x squared. And for negative 16, I still have minus here because I haven't dealt with the minus sign here. Do not lose that. But I have 2 times 2, which is 4. And I also have the x here. And then I have dealt with this 2 times 2 already here. So that means I am still left with 2 over here. So that's going to be plus 2. And again, I can check to see if my answer is correct by doing the distributive method. Oops, I do want to change the color. Distributive method. 4 times x squared is 4x squared. 4 times negative 4x is negative 16x. 4 times plus 2 is plus 8. And that's what I started off with. Okay, let's try level 2. Factor out the greatest common factor. This time we're dealing with a lot of variables. Okay, we don't have any coefficient in the first term. That means 1 is the default number here. Well, 1 is a common factor to all of them, but that's always the case. So there are no common factor coefficient. There is no number that is a common factor. So we need to be looking for variables at this point. Okay, we always look for variables too. So we look for greatest common variable factor. In this case, I know that x to the power of 4y, and I have 4 times x squared y and negative 3xy squared. I know that x to the power of 4y is really x being multiplied to itself 4 times by y. 4x squared y is 4 times x squared, x times y, and 3xy squared is 3 times x times y times y. So looking at all the variable, what is common to all three of them? I see the xy here, and xy there. That means xy is common to each one of the terms. So I take xy out in front of the parenthesis, and then I am left with x times x plus, after taking out xy, you're left with 4x. And after taking out x, y, y, you are left x, y, you're left with 1y and 3. It's actually negative 3. Okay, so then this simplifies to xy is, in parentheses, x times x is x to the power of 3 plus 4x minus 3y. Okay, so at this point, you are going to be doing some more problems. So please pause the video and try to factor out the greatest common factor first. Okay, so first thing is you look for numbers, the coefficient, to see if there are any factors in coefficient. And once you're done with that, you look for variables. Okay. Okay, since 3x to the power of 4 is 3 times x times x times x times x, and 2x to the power of 3 is 2 times x times x times x, and minus 3x is negative 3 times x, I can see that x is common to all three. So I take x out, and you're left with 3x times x times x times x, which is 3x cubed, and then 2, you've taken out x, so you're left with 2x times x, which is 2x squared, and then minus 3. And again, you can multiply it out using the distributive method to make sure that your answer is correct. For the second problem, x squared y is x times y, and minus 16xy is 16 times x times y, and 3y is just 3 times y. So common to all three terms is just a y, so take y out in front of the parenthesis, and you're left with x squared here, and then negative 6x, and then plus 3. Okay, so again, if you want to check your answers, you can always distribute y to x squared and then to the second term and the third term to make sure that you're doing it correctly. Okay, so let's put it all together. Factor out the greatest common factor. So you always need to check for great GCF. That's greatest common factor in the coefficient. That's the numbers in front of the variables. And then you look for GCF for each of the variable. So in this case, 4, 20, and 12, what is the greatest common factor, that a number that is divisible by all three? That would be 4, right? So I take 4 out, and then you're left with x, y cubed plus 4 times what is 20x squared y? That's going to be 5x squared y. And then 4 times what is negative 12? That's going to be negative 3xy squared. And now I am looking for the variables, xy cubed, x squared y, xy squared. Okay, I hope you're starting to see that xy is common to at least, I see at least one x in each of them, and I see at least one y. So that means I can take out x and y as well, and that leaves me with y squared plus 5x minus 3y. Okay, again, you can multiply this back out using the distributive method to make sure that you're getting the same answer as what you started off with. Okay, and then we did some more practice problems. Again, check for GCF in the numbers, coefficients, and then also the variables. Please pause the video and try these problems. And the answers are And then finally, the last thing we did was you submitted the class notes in Canvas on the 12/7 classwork. Thank you for listening.